Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Oscillations. So any doubts, if you have in any steps, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told a pendulum oscillates simple harmonically if the size of the bob of the pendulum is negligible in comparison to the length of the pendulum and the angular amplitude is less than 10 degrees. So it means when a pendulum is oscillating, then the size of the bob should be obviously less than the length of the pendulum. Means the size means I can say the radius of the bob should be much less than the length of the pendulum. It means the size of the bob should be negligible as compared to the length of the pendulum. So and it will oscillate simple harmonically if the angle which is also called the angular amplitude, that should be less than 10 degrees. It means the angular amplitude should be very small, should be a very small angular amplitude. So it means option A is the correct answer. Means both the statements 1 and 2 are correct. Both the statements 1 and are correct. Then here it is told that the displacement of a particle executing SHM is given by x equals to 3 sine 2 pi t plus pi by 4, and where x is in meter and t is in seconds. The amplitude and the maximum speed of the particle is. So if the equation of motion of the particle executing SHM, the equation of motion of the particle executing SHM is given as x equals to a sine omega t plus phi, where phi is called the initial phase angle and omega is called the angular frequency, the angular frequency, and the a is the amplitude of the SHM. So if we want to find the speed, then we have to find v, that is dx by dt, which will be equal to a omega cos omega t plus phi. So it means therefore the maximum speed will be equal to a omega, and here the a is the amplitude. So here if we compare this equation with this equation, then we can see that here the amplitude is 3 meters and the angular frequency omega is 2 pi radian per second, and the initial phase angle is pi by 4. So therefore here the amplitude is 3 meter and the maximum speed which you have to find, that will be a omega, which is 3 into 2 pi is 6 pi meter per second. That means that option A is the correct answer. Then here it is told that a block of mass m is connected to a light spring. A block of mass m is connected to a light spring of force constant K. The system is placed inside a damping medium of damping constant B. Damping constant B. Damping constant B. The instantaneous values of the displacement, acceleration, and energy of the block are X, A, and E respectively. So there is a damping force. We know that the damping force is proportional to the velocity. It means the damping force, we can say it is equal to minus BV, which is minus B dx by dt. And the spring force is also acting. So it means the net force acting on it, acting on the block, equals to the spring force and the damping force. So we know that the net force is given as mass into acceleration. So that is equal to the spring force, which is equal to minus kx, and the damping force, which is minus b dx by dt. And acceleration, we can also write it is equals to d square x by dt square. Since why it is dv by dt. So therefore, we can say that m d square x by dt square plus b dx by dt plus kx equals to 0. So this is the equation of motion of the block. This is the required equation of motion of the block, which is under damped simple harmonic motion. So it is the equation of a damped SHM. Now if we solve it, then we will get x as x will be equal to a e raised to minus bt by 2m cos omega dash t plus phi, where omega dash is equals to root over k by m minus b square by 4m square. So it means all these options, so option B and D are the right expressions. The expressions which are mentioned in B and D, they are correct expressions. So here we are being asked to find the incorrect expression related to the damped oscillation. So these are correct expressions. So the energy, the energy is equals to half into k a square, where a is this. So if we do the square of this, so then we will get a square e power minus bt by m. So it means option A is also correct expression. So it means the option C is the incorrect expression. So option C is the correct option. Option C only is the incorrect expression. Correct expression. So it is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam. Still any doubts if you have, then please write that in the comments. Also, please install our Sapience Education application, where we shall upload some important questions based on the previous year KCET exam. So thank you everyone. Bye.